Can a computer predict a flashover before it actually happens? Stop thinking that predicting fire behavior is just a guessing game for the incident commander, because the era of artificial intelligence has just turned the fire engine into a literal time machine. When you dive into the advanced levels of fire engineering, you are immediately introduced to Computational Fluid Dynamics, or CFD, which is the absolute gold standard for understanding how fire breathes, moves, and destroys. CFD mathematically divides a room into millions of tiny 3D cubes and calculates the exact transfer of heat, the exact flow of toxic gas, and the exact consumption of oxygen in every single cube using incredibly complex fluid mechanics, like the Navier-Stokes equations. But here is the massive, fatal flaw that every safety engineer eventually realizes. Calculating that level of math is so incredibly heavy that a simple 10-minute fire simulation for a single room can take a high-end supercomputer days or even weeks to finish processing. Relying on traditional CFD during a rapidly escalating emergency is like trying to calculate the exact physics of a bullet while it is already flying at your head. By the time the computer finally prints out the warning that the structural steel is failing, the building is already reduced to ashes. We desperately needed a way to get the flawless accuracy of CFD without the unbearable waiting time. And that is exactly where the machine learning revolution is changing the entire foundation of process safety. Instead of forcing a computer to do the heavy math from scratch while the building is burning, software engineers are now pre-training advanced AI neural networks on millions of those slow, completed CFD simulations. The AI effectively memorizes the complex physics of thermodynamics and fluid dynamics natively. So, when a real fire breaks out, the AI doesn't calculate the physics, it instantly recognizes the pattern. We feed the AI model live, real-time data from the building's IoT sensors, instantly capturing the sudden spike in temperature, the rapid drop in oxygen, and the specific combustible fuel load present in that exact room. In absolute real time, without a single millisecond of lag, the AI instantly predicts the exact second a flashover will trigger, maps the invisible spread of toxic carbon monoxide traveling up through the HVAC system, and most importantly, calculates the thermal degradation of the structural steel beams. It gives the incident commander a digital crystal ball to see that the fourth floor support beams will reach their critical failure temperature of 600 degrees Celsius in exactly 12 minutes, allowing them to order a targeted, precise evacuation long before the physical disaster actually strikes. We are no longer just reacting to the flames with hoses and hoping for the best. We are mathematically outsmarting the fire before it even realizes it is burning. Stop waiting for the heavy math to finish. Start engineering the real-time prediction. And make sure to subscribe to Decode to master the absolute bleeding edge of safety technology.